So we will take a look at some of the features that are already in Research Suite, mainly on the calculation ADT side, and also we will take a look at what's coming up. So as the title suggests, we are looking at formulation-related capabilities. So first, disclaimer, some of the features and screenshots you see are still under development. Some are in early stage, some are in late stage. So I want to go through today's presentation in this sequence. First, I want to talk about the idea of building a consortium to guide us and help our customers to really develop features that can be really useful in get-go. So the idea of forming a consortium. And now to talk about ADTs. ADT stands for Admin Defined Table, or use my own personal language, I think it really is advanced data table. Because representation of a formulation is critical in the formulation workflow. So building a powerful yet user-friendly data table is really the key, right? Right now, I think a lot of users are using Excel to do a lot of functions. Excel has advantages, but also a lot of disadvantages. That's why we're addressing the disadvantages of Excel. I think that's the right way to help our users to do their formulation workflow. And then I'll talk about what's coming on the horizon. The main task right now is to basically go from one formulation table to multiple tables and put them in a structure that makes sense both for further data processing perspective and also for scientists in the context of design of experiment. And then I will summarize the future plan altogether. So first, the idea of consortium. For any software company to be successful, I think it's very important to start with customers, right? Start with the problem. And Revvity Signals is no exception. That's why earlier this year, we started this effort to form a consortium by inviting some customers in and get on this development journey together. So we start by collecting customer use cases, by listening to customers' voices. And then through our own professional service team and product development team, we basically integrate these ideas together, put a definition, and then design some solutions around, and eventually build a product. And then we go right back to customers to get validation, and then we, based on the validation, we improve. So this is a continuous cycle, and we want to make sure both customers and Revvity Signal teams are together on this journey. So that's the process. And also we realize, meanwhile, this new set of formulation capabilities have to meet these two objectives, right? First is we still, as a software provider, we are keenly aware of the importance of user experience. So through this journey, and we want to make sure we do our best to provide the best customer experience or user experience possible. And the second goal is because we support a variety of scientific disciplines. So we want to make sure that in this formulation development, capability development process, we also support many workflows. That could be process chemistry, purely formulation, and analytical, and also governed by certain GXP principles. So as you can see, it's not easy to balance the two, right? You want your tool to be as powerful and yet user-friendly as possible. At the same time, you want to make as many users happy as possible. So we constantly balance between the two, and we always welcome users' input. So, okay. So ultimately, the goal of this consortium is to build a community, achieve certain amount of consensus to guide development, and then iterate. That's a keyword. Software development is always iteration, right? There's development, there's a debug, there's validation, and then probably have to repeat that process again and again. And also we want to provide visibility into our user community to collect input and to further improve the user experience, so to make it useful. So that's the consortium idea. Now I want to talk specifically about admin-defined tables. In this entire section, actually in 2, all these features are available today. So we view formulation, I think, in the context of a workflow. I know the data table is the most important part, right? But formulation is more than just putting rows of data in one data table and somehow using a mathematical equations to or abstraction to represent that. It's bigger than that. That's why I want to talk about formulation capability in the context of a workflow, or more specifically, chemical product development workflow. So from the start, we have this capability to use a template to design an experiment. So all formulation-related data is actually part of an experiment. And we allow users to define their template through a set of user admin level privileges. So the starting point of a formulation is always a new experiment. And that's basically, if you think about computer programming, that's the starting object. And everything happens in the context of experiment. That's how data is organized. That's how data is indexed. So starting with the experiment, you create certain fields and put information in, and then later on, all this information will be available for search and further analysis. And as I explained earlier, the critical part of formulation is the ADT, is this data table. And the way to really take the most advantage of this data table is in the table design template. And that privilege belongs to admin level users. So each column here represents a form of data type. So basically, in this case, trade name, that's a string. In this case, real mass, that's a number. So at very high level, there are basically 3 data types. One is string, type it in. One is number, either calculated or it's typed in. And then the third is data import. So each table will allow users to define data source. So you can go into internal data source or external data source to query a field out of your data source and put the information in this table. So as long as ADT defines that, the average user can just query data the way that's defined by the admin. And those features, they're all available today in our ADT design. So if the data is queried, that means every time the user opens this table, if there's update on the server side in the database, and that will be reflected in the data table. And then that will trigger all the calculated cells. And most recently, we added a whole bunch of new functions in calculation, so you can build in expression. So there's data, and then you can say, okay, if such thing bigger than something or smaller than something, then the value of that cell is equal to A or B. So I think those features just have been released recently, and please take a look at that, like that. So in a way, we are adding a lot of calculation functions that are available in Excel to help formulation team to not only put in static data in the data table, but to make this data table really smart, can make decisions. And we believe that's the that's a really important cornerstone of a good formulation workflow. So we made this ADT table features much more powerful just compared to like a month ago. So the result is, as I explained, if you set your data table the way like this, which I think is typical for a material science company, you could do a query using predefined data source and way. So you basically search this raw material, and then its ID will be imported as part of the table, and all associated fields, the black strings, they are basically imported data, and the blue ones, they are user put in. So as you can see, there are many types of data, right? Even including the table header, all these numbers. So this is user created number, is plant mass. It's just the number is 1,000 gram. Formulator is a string, and the recipe reference is referencing another data table, basically. Yeah, you can reference table inside a table, and all these blue fields will be used to can be used for further calculation. And the one thing I want to point out here is this date, right? So that date is not a static date. That date is imported as a data structure. So if you create two tables, you can have different date, or you could put that date field in one of these columns. And that data, once it's keyed in, it can be used for further analysis. So if you are calculating like how long the reaction time is, you can take two data points. They are both in the date format, and then you can do further calculation based on those numbers. I still have to validate whether we provide that calculation, but that data type is available. So I'm sure if we don't, it shouldn't be too hard to perform some kind of calculation based on this data type, date, and the time. So it's just about how you design that. And meanwhile, as I mentioned earlier, formulation is more than an exercise of data table, right? All this contextual data, metadata is also very important, which we provide. But through ADT, you have to link that information. So this is the example of a raw material that's in our material library. So if you reference this raw material in the data table, you can create a link, and you can get information from this database, and including, in this case, the SDS type of PDF format. So all this information is in the material library. And as I think Jen will talk about this later, now our inventory management system, in addition to properties, it also allows physical tracking of your inventory level, deduction of certain amounts from this inventory. So every day we are looking at what are the most popular use cases and the beneficial use cases to our users, and then we add them to help really make this formulation a process, a comprehensive process, and provide visibility into this entire process. So that's also available today. And for more complicated and involved sequence of events, we recently added worksheet. So worksheet is basically, I think it as a way to thread different objects or entities in our signal notebook together. You can define, okay, you do this first, you check this process, and again, this worksheet has to, probably anything, it even requires more admin level privilege, because you really have to specify each step, what you want to get, what you want to check, but that's all available in the context of worksheet. So as we covered, we have individual formulation table, which now gives you a lot of calculation, logic, expression type of capability. And then we have very similar table to help you do the formulation workflow, define a sequence of procedure, and then more involved worksheet. So these features are all available today. So if you are admin, please go test them out and see if first any bug you can report, and also how you can best to use those features. And now, of course, signing, as we talked about yesterday, that's the native part of Signal Notebook. And, again, this is part of the workflow definition that admin type of users needs to either enforce, or for some organizations, like I worked in the chemical companies, I mean, this is not really a required step. So it's all up to the user to define whether, like, what are the steps in your formulation work. So, and formulation does not just happen in Signal Notebook. Yes, basically, if there's a table in Notebook, that's a thing, okay? Whether you treat it as a sample, or you treat it as a data table, or a formulation, that's subject to debate. But that thing is there. And if that thing is there, you can import it out. You can take it to Inventor, and you can perform statistical analysis on this formulation. So here is basically an example of each row here is a formulation. But in this case, it's basically a link to a data table or a URL somewhere. And each chart represents a analysis of these formulations comparing to each other in certain testing results. I will go skip that again. As we learned yesterday, there are 45 different types of Spotify charts, and they're all available through our delivery in terms of Inventor. So it's very powerful tool. And all these charts, one thing is they're interactive. That means data goes into Inventor, and also data, you can click on this chart, and then it will bring set of new information. And then eventually, we're working on porting that data out of Inventor and back to Notebook to complete this DOE process. That's in the works. But Spotify provides excellent and very powerful scientific analytical tools, and very good user experience. And you can click around and do things, which, you know, Excel charts, you can't really go from chart to data. I mean, pivotal charts maybe a little bit, but not to the same level as this tool. So the next step is really, now we make this one formulation table a standalone object, right? So the goal is to represent multiple of them in a logical way. So companies can proceed to next step, which is to collect the data and compare them. So this is currently in the works. We are looking for input from our customer user base on what's the best way, right, to really group related formulation tables together in a scientifically meaningful way. But this is one example that we are doing. So basically, you want to go from a base formulation, create variations or derivatives of that based on either your historical information or based on your brainstorming suggestions from scientists. So the way we think we want to achieve this is first to define what this basic table or parent table looks like. Basically defining columns. So in this case, a formulation has ingredients. So in this table, we define how many ingredients is needed in this formulation DOE process. And then the next step is to, we just run here, run here, but this really variations of this formulation table. So you can see, you can change order of addition, or you can change percentage weight. And there are many ways to make the formulation vary. And so that's something currently the consortium is working on. But the goal is to really go from one formulation to multiple, and then provide the user a way to really compare them visually, right? And also to allow a data structure that will eventually be used by inventor for, say, analysis of variance type of statistical analysis. So that is the goal. But visually, this is what a multiple table looks like. I mean, I know basically you have multiple tables, right? You have multiple two-dimensional objects. What's the best way to stack them together and give a visual pleasant experience to compare them? And that we're still finding out what's the best way to do that. In my opinion, there's no really there's no single best way, because different users, they want to experience, they want different experience. Some people want to go up, down, some people want to go left to right. Some people like me, I just want to see a 3D structure, but it's possible to do that here. So there's still some debate, but at least that's the direction we're moving to. We're going from one formulation table to multiple. So this is the last slide. Yeah. Green boxes are pretty much done. Okay, so we enhanced our calculation features. I think if you have time today, I'd like to show you. You can do if, you can do else, you can do sum if, you can do statistical, like find the variance or standard deviation type of calculations. And we are currently working on variation table. Maybe I think we are 50% in this box. And then eventually, with all this data structure defined, we want to basically make formulation library a thing. So you go from one table to multiple table, and then including mixing procedure, all that's defined as a library type, and then to allow data flow between notebook and Eventa, and create expanded, and then premix will be part of that as well. So define one table, just import that table to another table, and then find an easy way to perform all the calculations. So that's premix, and then eventually data pipelining. I think that will give DOE a complete package. And ask me about timeline later, so but it's coming. I just want to say today we already have a lot of calculation capabilities that you can take advantage of. And yeah. Thank you.
Thank you, Jun.